Good morning, afternoon, evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to talk about solving multi-step equations, but this time we're going to talk about multi-step equations that involve fractions and decimals, the nemesis of most students. They see fractions, they see decimals, and they flip out. Today, hopefully, I'm going to show you how to eliminate that fear and show you how to work with that. And of course, guys, I know I'm repeating myself a lot, but I want to make sure that I drive this point home. The goal of any equation, I don't care how complicated it is, the goal of any equation is to isolate the variable. Okay? And we're always solving for x. Excuse me for 1 second, I'm so sorry. Sorry about that. Okay, so again, guys, we want to solve for x over 1 in the numerator positive, okay? That's just the same goal regardless of how complicated or how simplistic the equations are. The procedures for solving multi-steps, we know these already. Step 1, complete any distributive property first. So repeat. Step 2, combine like terms on both sides of the equation. Nothing new here. Step 3, move all the variables to one side. And now, gentlemen, you're left with a two-step equation, my brothers. So now you undo addition and subtraction. And then, last but not least, you undo multiplication and or division. So this is nothing new. I'm not trying to diminish the fact that we already learned this, but I want to reinforce it because it's very, very important that you know this backwards and forwards. So that being said, guys, how does this work with fractions and with decimals? Yes, sir.
Don't you undo multiplication? Oh, actually, never mind.
You undo multiplication division at the end. That's going to be the last one. No, I thank you very much. Remember, in a one-step equation, depending on what you have, it's either addition and subtraction, which you get rid of, or multiplication and division, which you get rid of in a one-step. But in two-step and multi-step, the last two steps, once you have a two-step equation, undo addition and subtraction, then last but not least, undo multiplication and division. Yes, sir?
You have an equation over another equation as a fraction.
Yeah?
Treat it as division or as subtraction.
No, remember we talked about that. When you have, and you don't have an equation over an equation. You mean if you have an expression over an expression, let's say minus 2 equals 6. Remember what we said? You cross multiply. Just like in our homework, right? And then this would become x plus 3 equals 6x minus 12. Then I'm going to subtract the x to both sides, combine, get all the variables on one side. Then I've got 3 equals 5x minus 12. I got lucky with this. I did not expect this to be so pretty. And that's 15 equals 5x. I undid subtraction. And then I divide by 5. And x would equal 3, right? Thank you, sir. Okay. All right. So, how does this work with fractions? Okay, guys. Please listen to me clearly. Do not try to do your own method by skipping steps. Okay, you want to do it the long way? You can. God bless you. I totally do not suggest it. I love fractions, actually. I'm really good at them. And I don't work with fractions usually on equations because it's more efficient to get rid of the denominators. So the most efficient way to solve multi-step equations involving fractions is to eliminate the denominators of all given fractions by multiplying both sides of the equation by the LCD, the least common denominator. Once complete, all fractions have been eliminated, and you can proceed to solve the equation with ease. Now, the long way, I'm just going to briefly describe it. I'm not going to do it. The long way would be to find a common denominator of 4 and 3, change both of those fractions, add them together, and then solve. A lot of times people get confused with that, and I get it. So what I'm suggesting is to find the LCD for sure, which is what? 12. Now, I want to get rid of the fractions, gentlemen. So I'm going to multiply both sides of the equation by 12. So what does that mean? Remember that this is a 12 over 1, guys. So I'm going to go step by step. As you get quicker and better, you can see it in your head and you can start simplifying, but I'm going to go step by step. 12 times 3 is x is 36x over 4 minus 12 times x over 3 is 12x over 3 equals 12 times 10 is 120. Well, 36 divided by 4, we got 9x minus 12x divided by 3 is 4x equals 120. No more fractions. They're gone. 9x minus 4x is 5x, which equals 120. Now I divide 5 to both sides to undo multiplication, and x will equal 24. It's that simple. Will the numbers always come out beautiful and pretty? No. Sometimes the numbers will come out as fractions or mixed numbers even, the answers. But the work you're going to be doing will not have fractions involved. That's not too bad, right? Okay? Yes, sir. Thank you for asking. 36x divided by 4 is 9x. 12x divided by 3 is 4x. Thank you very much, sir. No, why will you cross multiply? Thank you for asking, though. Takes guts. Thank you. All right. So let's see what else we got here. Okay, number 2. Someone said it real quick. I'm proud of you. 20 is the LCD. So I'm going to multiply 20 to every single piece or term of this equation. So 20 times 2x over 5 is 40x over 5. 20 times 2/4 is 40 over 4. And 20 times 5/2 is 100 over 2. Again, some of you may be saying, Mr. Morrow, can't you just do that in your head? Yeah, I can. And you will be able to as well, but it's going to take some time. What do I mean? Well, if I'm going 20 times 2 over 5, I'll do well. 20 divided by 5 is 4. 4 times 2 is 8. But sometimes that takes a little bit of time. So it's no big deal. 40 over x is 8x. 40 over 4 is 10. And that equals 100 over 2, which is 50. Two-step equation, subtract 10 to both sides. 8x equals 40 divided by 8. X equals 5, gentlemen. Easy peasy, lemon squeezy. No worries here. Get rid of the denominators. Yes, sir, my brother. Of all the fractions, you find the LCD, brother. Thank you, my man. How about here, gentlemen? 18 is the LCD for number 3. Excellent. So I want to multiply 18 to everything here, guys. 18 times 1/9 is 18/9, my brothers. 18 times 5, that's, what is that? 90. That's 90 over x. Thank you, gentlemen. And 18 times negative m over 3 is negative 18m over 3. Now let's simplify. Let's make our lives easy. 18 over 9 is 2. 90 over 6, I believe, is 15? Yeah, 15. And negative 18m over 3 is negative 6m. Now I've got a two-step equation. Subtract 15 to both sides. We've got negative 13 equals negative 6m. Divide by negative 6. And m equals 13 over 6, or 2 and 1/6. I will accept either answer, mixed number or improper fraction, unless I specify. Please write all answers in mixed number. Okay? What we always need to do, though, regardless of if it's mixed number or an improper fraction, we always reduce. Always. Okay? Now, I'm going to get to a little bit of a tricky one here. And I need you guys to be honest. Okay, yes, sir. Oh, okay, for number 4, yeah. Let me teach it. Thank you very much, sir. Okay. Two options here, guys. Two options. But you must pay attention to the type of problem you have. Option number one, where I think is the easiest. This 3/5 has yet to be distributed, correct? Does that make sense to everybody? So do you think this would make sense? If I multiply this by 5, 5 times 3/5 is 15/5, which is still outside. This has not been distributed. So you got x minus 20. So this 5 only affects this. It has not affected this yet. Not yet. And then 5 times 9 is 45. From here, 15 over 5 is 3 times x minus 20 equals 45. Now I can work with this. This is 3x minus 60 equals 45. Add 60 to both sides. 3x equals 105 divided by 3. X equals 35. Yeah, 35. That's one option. Please be careful if you use that option. When you have a fraction, okay, being multiplied to a parenthesis, you can multiply it by that single denominator and make that fraction that's outside of the parentheses a whole number. Okay? The mistake that people make here, though, is they multiply the 5 to this and this as well. No, not yet. Why? Because I have not distributed that 3/5 yet. Does that make sense, guys? Now, some people don't see that. They get confused, and that's okay. Another way to do it, gentlemen, is to first follow the multi-step procedures and go ahead and multiply that 3/5. So I've got 3/5 x minus 60/5 equals 27/5. That works as well. Now, what do you think I would do to get rid of those denominators of 5? No. You're right. Yes, I would. Thank you, son. Good man. So now I multiply by 5. Thank you, brother. Good catch. Excellent catch. Very proud of you. So now I've got 15x over 5 minus 300 over 5 equals 45, which then gives me 3x minus 60 equals 45. And then I'm left with this part right here. And you're going to get the same exact answer. So you've got two choices here. I suggest you choose one, memorize it, learn it, and run with it. Yes, sir, and yes, sir. Okay. The question was, why must we be careful of the first method? Let me show you once again. What happens here a lot of times, my brother, is if people multiply by 5, they'll go like this. Okay, this is 15/5 times 5x minus 100 equals 45. That's wrong. When you're doing it the first method, you're trying to get rid of this denominator and that denominator only. So 5 times 3 is 15 over 5, and that's it. You stay there. Then you simplify that, and then you distribute. That's the danger. So if you think that's going to be a possible danger for you, don't do it. Don't do it. That's why I like to teach as many ways as I can things, because some people like one way, some people like another way. It doesn't matter what I like. I will never be that teacher that says, no, you have to do it Mr. Morrow's way. No, you got to do it the right way. The right way is not necessarily Mr. Morrow's preference. If I teach you 2-3 different ways to do it, you do it those 2-3 different ways, the way that makes sense to you. Okay? Does that make sense, guys? Yes, sir, my brother. That instead of negative 20 has a fraction. Yeah, I absolutely can. Let's, hold on, let me make sure that No. Okay, that's decimals. Yeah, let me give you one. Good question. It's going to be ugly. I'm going to tell you right now. Let's just do, I don't know. Let's go 3/4 times, let's go 2x minus 1/5 equals 12. It's going to be nasty, okay? But it is what it is. How do you want to do it? Do you want me to get rid of that 4 first and then distribute? Or do you want me to distribute the 3/4? Which way do you think, are you leaning towards? Okay, so then I multiply by 4. This goes to here and only here, which is 12/4 times 2x minus 1/5 equals 48. You with me, my man? Yes, sir. I did not distribute it by 4. I multiplied by 4 because I want to get rid of the denominator of 4. Okay. Thank you, my brother. So then this is 3, 2x minus 1/5 equals 48. Now I distribute. 6x minus 3/5 equals 48. Do you want to work with a fraction? Now I multiply everything by 5. I got 30x minus 15/5 equals 240. Now I've got 30x minus 3 equals 240. I told you it was going to be ugly. Add 3. 30x equals 243 divided by 30. And then that goes in 8 times with 3 left over. So that would be 8 1/10. Sir. Or you could have distributed the 3/4 from the beginning and then had 6x over 4 minus 3/20 equals 12. And then you find the LCD for that, which would have been 20. Multiply that to everything and then solve from there. That's a personal decision. I can't tell you one is easier than the other. I know what's easier to me, but who cares about that? What does that have to do with the price of apples in Japan on Thursdays? Not much, right? Because it's up to you guys. I need you guys to start focusing on what works for you. You have autonomy in this class, okay? Does that make sense, brothers? Thank you. Yes, sir. What? No. What are you not really sure of? That's my job. Thank you. Oh, you're a little behind? Okay, no worries. That's why I have a video. Thank you, sir. Okay, now, solving equations involving decimals. This is a lot easier, in my opinion. The most efficient way to solve multi-step equations involving decimals is to estimate the decimals of all given values by multiplying both sides of the equation by the correct power of 10. In order to find the correct power of 10 to multiply by, simply look for the largest number of values to the right of the decimal point and multiply by the power of 10, which matches the number of values to the right of the decimal. Once complete, all decimals have been eliminated, and you can proceed to solve the equation with ease. Okay, what am I talking about? Okay, I've got 3.5 minus 0.02x equals 1.24. Look at the note that I have. Look at each value. What is the largest number of values to the right of the decimal? Okay, no. I've got one number to the right of the decimal, and then I've got two numbers to the right of the decimal, correct? So there's two numbers to the right of the decimal, correct? The 0.5 has one value to the right of the decimal. 0.02 has two values to the right of the decimal. 1.24 has two values to the right of the decimal. Therefore, you multiply both sides by 100, which is 10 squared. Why 100? Because I want to move this decimal 2 places to the right. And whenever I multiply by powers of 10, I'm moving the decimal to the right that many places. So what I'm going to do here is multiply by 100. 1, 2 to the right, that's 350. Minus 1, 2 to the right, that's 2x. equals 1, 2 to the right. That's 124. No more decimals. Easy, right? I just blew you away, didn't I? I'm very proud of you. Good. Look, guys, some people are going to say, yeah, but Mr. Moore, you know what? I don't like all that jazz. I want to do it in decimal form. I like decimals. Go for it, brother. I'm not going to cry about it. Your choice. This is just, it's easier without decimals. Yes, sir. No, you'll see the beauty of that. Once you solve for x, odds are your answer will be in a decimal. But then you're done. Okay. So, for example, here I subtract 350 to both sides, gentlemen. And then remember, when the signs are opposite, you subtract as normal. Keep sign largest absolute value. So that's going to be 226. Oh no, in this case, nice and easy. Came out beautiful. X equals negative 113. Wait. What are 236 really? Oh, negative. You're right. Sorry. I'm positive. Thank you, sir. Because a negative, more negatives than positive. Thank you, sir. Pay attention, Moro. Pay attention. Questions, comments, concerns, problems? Awesome. Thank you, my brothers. Okay, how about this guy? What do you think I will multiply by to get rid of those decimals? 1,000. Why? 1, 2, 3. Yes, very good, my brothers. So multiply by 1,000. 1, 2, 3 to the right. That's going to be 1,025x. 1, 2, 3 to the right. It's going to be 2 point. Come on, Moro. 2,458. Three places to the right. 7,583. Now you solve for x. Subtract 2,458 to both sides. So it's going to be 5, 13, that's 7, that's 2, 1, and 5. Then divide by 1,025. And that comes out to a beautiful 5 on the money. Yes, sir. If it's a whole number and you want to multiply everything by 1,000, I don't see why you would want to do that, but the answer is yes. Now, as long as you do something to both sides, it does not change the equality. You got to do it to both sides, though. But that would be silly and just very time consuming. If you're randomly going to say, I don't know, I want to multiply this by 1,000 now. You can, bro, but you make sure that you do it to every single value on every single side. Okay? Thank you, gentlemen. Does that make sense, boys? Okay. And voila, we are done. Thank you so very much. Hope you learned a lot and have a wonderful, wonderful day.